Welcome back. Now that we've introduced what AI agents are, let's talk about how they actually work and what you need to build one. At the heart of any AI agent is a large language model, or LLM for short. This is the brain of the agent. Think of models like OpenAI's GPT 3.5 or GPT-4. These are LLMs that can generate text, reason through problems, and even write code. The agent uses the LLM to handle the thinking part, analyzing the goal, coming up with a plan, and deciding on actions. But an LLM on its own is just a predictor of text. It doesn't naturally perform actions in the real world, or remember things beyond its prompt. That's where the rest of the pieces come in. One important piece of an AI agent is the set of tools it can use. In this context, tools are essentially functions or actions outside the AI's own mind that it can invoke to help it solve the problem. For example, a tool could be the ability to search the web, to run a calculation, to access a database, or to control a web browser. If you've used ChatGPT plugins or heard of them, it's a similar idea. The AI can call on a tool when it needs. For instance, if the agent's task is to gather the latest news on a topic, it might use a web search tool. If it needs to do math, it could use a calculator tool. So, as a developer, you define what tools are available to the agent. Part of building an agent is, connecting these tools and making sure the AI knows when and how to use them. Another key piece is memory. Humans solving a complex task take notes or recall previous steps. AI agents need that ability too. Large language models do have a context window, which means they remember a certain amount of text conversation. But for truly autonomous behavior, we often extend their memory. One common approach is using a vector database as an external memory. Don't worry if that sounds complex. A vector database is just a fancy way to store text, like the agent's observations or past actions, in a form the AI can search through later. Open source options like Chroma or Face let you do this for free. In practice, memory means if an agent learns something useful or encounters an intermediate result, we can save it and feed it back to the AI when needed. For example, if our agent is doing research, after finding each relevant article, we might store a summary in memory. So, later on, if the agent needs to recall what it learned, it can just retrieve that information instead of searching the web all over again. This honestly makes the agent more efficient and even a bit aware of its past. Now, tying it all together is the concept of an agent loop or framework. Basically, this is the logic that surrounds the LLM, and it's what enables it to function as an agent. Typically, here's how it works. The agent gets a goal or a task. Then it goes into what's called a think-act cycle. The LLM comes up with an idea of what to do, like, I should use tool X to get info Y. The agent then executes that action, gets a result, and the LLM gets to see that new information and decides what to do next. So basically, this repeats until the agent considers the task done. To implement this loop without having to code everything from scratch, we actually have some fantastic open source frameworks. One of the most popular is LangChain. LangChain provides easy ways to connect a language model to tools and memory. With LangChain, you can define a few tools, like say a Google Search API and a calculator, give the agent a prompt that tells it can use those tools, and LangChain handles the interaction loop. So, it will call the model to decide an action, run the action, feed the result back to the model, and so on. This actually saves you from having to write the entire agent logic manually. Besides LangChain, there are, other frameworks and projects to be aware of. AutoGPT is one that made headlines. It's an open source project where you configure an AI agent with a goal, and it tries to complete it by generating tasks and executing them autonomously. Under the hood, AutoGPT uses an approach similar to what we described. It uses an LLM, originally GPT-4 or GPT 3.5, and a loop of reasoning and acting, along with tools like web browsing or file access. If you peek into AutoGPT's code, you'll find it's doing planning, using memory, and even writing to files to store information. Agent GPT is another name you might hear. It's essentially a user-friendly wrapper around the same concept. Agent GPT provides a web interface where you can name an agent, give it a goal, and watch it think and act step by step in your browser. So, it's built on open source foundations. It actually leverages libraries like LangChain under the hood, and, well, it became a pretty popular demo because you could spin up an autonomous agent without any coding, right from a website. There are also simpler templates like Baby AGI, which was a minimalistic script showing how an AI could, create and prioritize tasks in a loop to achieve a goal. And there are specialized tools like GPT Engineer, which focuses on generating full code projects by having an agent-style process that, iteratively refines a code base. The landscape is honestly rich and evolving. New orchestration frameworks like Microsoft's Semantic Kernel or projects like Super AGI have been emerging, each offering their own twist to help developers manage prompts, tools, and workflows for agents. The good news is that most of these are free and open source. You can read their code, learn from it, and even modify them for your needs. To summarize the key components you'll need for building an AI agent, an AI brain, like a large language model, some tools for it to use, a memory mechanism if the task is complex, and a framework or logic loop to tie it all together. In the next part of this series, we'll get our hands dirty setting up these components in a real environment. We'll choose some accessible tools, yes, including LangChain and possibly an open source model, and walk through the process of creating a simple agent. The focus will be on practicality, using free resources and common libraries so you can follow along on your own machine. By understanding these core pieces, the brain, tools, memory, and orchestration, you'll be well equipped to start building and experimenting with AI agents. Exciting stuff, right? Let's move on and set up our development environment to actually build one of these agents from scratch.